So to start this lesson off, I'm going to pose this question to you and see if there's anything that we could use that we've talked about so far in this class to find any of the missing measurements in this triangle. Can't use Pythagorean theorem because I don't know that it's a right triangle. I can't use regular trigonometry because, again, it's not a right triangle. Or I don't have enough information to say if it's a right triangle or not. And I can't use law of sines because 65 degrees matches up with the unknown side, and that would be okay. But 4 and 5, these two other sides that I've been given, match up with angles that are missing as well. So I would have one equation with two things that I didn't know, and we can't do that. So for a scenario like this, I have the ability to use law of cosines. And you'll notice that if I was to cover up this piece right here, it would be the Pythagorean theorem. So what this extra piece does is this takes into account that I don't have a right triangle. And so we're not really going to get into depth into what that extra piece means, but this is how the Pythagorean theorem kind of applies to or works alongside with the regular trig that we know to get myself to missing sides of a triangle that is not a right triangle that I can't use the law of sines for. So we're going to do one example that's off of this, and I'll make this a little bit larger. It's probably difficult to see. So let's say that I pose to you this picture here, and my mission is to find the side BC. Because I have two sides that are given, but it's not a right triangle, that kicks Pythagorean theorem out the door. It also kicks right triangle trig out the door because it's not a right triangle. Law of sines wouldn't be helpful because I, again, would have two missing angles that I couldn't match up 26 or 14 with. So ultimately, this is the side I'm trying to find. This would be a law of cosines scenario. And one thing I want you to notice, I'm going to flip back to the example or the actual equation. This side C is the side that's across from the angle that I'm using in this last chunk here. So here, I'm trying to find x, and x is across from 119, which is my obtuse angle down here. So when I set up the law of cosines, x is the one that's all by itself on the other side of the equal sign. This is what I would consider my hypotenuse on a right triangle. So c squared is the one that's going to be all by itself. Because I'm using x, we'll call it x squared. And then the first part of this is just like Pythagorean theorem. So I'm going to have 26 squared plus 14 squared. Now is where trig comes into play because I have the minus 2 portion. It's going to be both of my sides, 26. I need to get some more room. So it'll be 26 times 14. Now I'm going to do the cosine of the angle that's across from x. And just to make sure that you can see that, I'm going to make that a little bit bigger. So now I'm at a point where my calculator can do everything else for me. If you'll notice, everything that's on the right-hand side of my equation is just numbers. I can literally go and type all of that directly into my calculator. So I'm going to say I have 26 squared plus 14 squared minus 2 times 26 times 14 times the cosine of 119. And I can hit enter. And you're probably thinking, well, Ms. Thompson, that's a really big number. And the reason being is this is x squared. And I'm going to extend this a little bit. So x squared is equal to 1,224 and the decimal places. So ultimately, my mission that I'm thinking of, and whatever else the decimal is, how am I going to get just plain old x? And ultimately what I'm going to have to do is take the square root of this number that I've been given. So now, in order to get myself to a final answer, I have to take the square root of this number that I got as my answer for the law of cosines that we did with our formula. So really, when I'm thinking about side x, because this is so close to 35, I'm just going to round it up and say 35. So I'm going to come back in here and say that x is equal to 35. Now it's nice and easy when I'm trying to find this missing side that's across from the angle that we've been given. But let's say I pose you the question of trying to find an angle using the law of cosines. So this is angle A that I'm going to try to find, and like we talked about in class, I'm going to use theta when I'm trying to find a missing angle. And what I want you to try to do this evening is see if you can set up how this would go into my law of cosines equation, and we'll talk about the process of actually solving for the angle in class tomorrow. But see if you can take the time and set up what the actual equation would look like for this problem that I've posed to you. And like I said, we'll talk about this tomorrow.